Hey guys, I'm going to go through the 8.3 homework, some trigonometry. Evaluate the 6 trigonomic functions of theta. So we have a coordinate plane, we have the two sides, we have the initial side, and we have the terminal side. Theta has rotated clockwise to this position right here. There is a point on the terminal side, and I'm going to make a triangle by drawing a line straight to the x-axis, perpendicular with the x-axis, perpendicular, making a right angle. And according to the values of this point, I can say that the leg on the x-axis is 4, and the leg that I made perpendicular to the x-axis is -3, according to our coordinate point right here. Now, that would have to, if I use Pythagorean theorem, so 4 squared plus -3 squared equal to c squared, if I follow through with that, I'm going to get that the hypotenuse is 5. And the hypotenuse is always positive whenever we're dealing on a coordinate plane of xy. And the other legs depend on whether which quadrant the terminal side is in. So we are in the 4th quadrant, which means that our x value is positive, but our y value is negative. So with that being said, you have to make the x and the y leg positive or negative according to which quadrant you're in, but the hypotenuse is always positive. And then, since we're going to use this as our angle of theta, we're going to get our 6 trigonomic functions from measuring from here, making this the opposite side, and this the hypotenuse, so sine of theta is going to be equal to -3/5. Cosine of theta, 4 would be the adjacent side, so 4/5, and for tangent, the opposite, -3 over the adjacent 4. For cosecant, that's going to be the reciprocal for sine, so that's going to be 5/-3. Secant is going to be the reciprocal of cosine, so 5/4. And cotangent is going to be the reciprocal, so 4/-3. And likewise here, so we have theta given here, we have the terminal side, we have the point. So from that point right there, I'm going to measure a perpendicular line to the x-axis, and I'm going to use the values of this coordinate point to indicate the values of the sides. So this side right here is going to be -12, and the other side is going to be -9. And they're both negative because this terminal side is in quadrant 3, making both x and y negative. And then I'll have to use the Pythagorean theorem. So we'll do, it doesn't really matter. We can just do 9 squared plus 12 squared equal to c squared. So if you have a calculator, go ahead, and we're going to solve for the hypotenuse, so it's going to be 9 squared plus 12 squared, and then you have to take the square root of that, and that's going to come out to be 15. So 15 is the hypotenuse here. Sine of theta is going to be equal to -9/15, but that can reduce to -3/5. Which is funny because that's the exact same as this one right here. They have the same sine ratio. Well, that's because these triangles are, they have the same angles. These triangles have the exact same angles that we measured here. And so their ratios, that means their sides are going to be similar, and that means their sides aren't going to be the same, but the ratios of the sides are going to be the same. And so cosine is going to be equal to -12/15, which can be reduced since they're both divisible by 3 to 4/5, -4/5. And then tangent is going to be equal to -9/-12, which is going to be equal to 3 over 4. So that is something that is different from this one over here, where tangent is actually going to be positive over here. That's because both sides are negative. So when we divide them, it'll be positive. However, with this one over here, only one of our sides was negative. And then for cosecant, that's going to be equal to negative 5/3, secant, negative 5/4, and then for cotangent, 4/3. And for 3, now you can see the value right there, okay? Very small triangle. Let me enlarge the triangle. So maybe to something like this right here. So I'm just taking this little triangle that we're making right here, blowing it up right here, and according to the coordinate, we would have 1 and negative 2. So 1 squared plus 2 squared has to be equal to c squared. Well, this is going to be 1 plus 4 is equal to c squared. 5 is equal to c squared, so c would be equal to the square root of 5. So that's our hypotenuse there. So sine is going to be equal to, well, this is the angle that we're using, the reference angle. That's going to be equal to negative 2 over root 5. But get rid of the radical in the denominator. That's going to be negative 2 root 5 over 5. For cosine, that's going to be equal to 1 over root 5. And same process, root 5 over 5. In tangent, it's going to be equal to negative 2 over 1, or just negative 2. Cosecant, I'm going to use the reciprocal, not of this one right here, but of this one, because whenever I use that reciprocal, I get root 5 over negative 2. And so now I don't have to get rid of any radical in the denominator. I already did just by flipping this right here. And then this will just be root 5 over 1, and this will be negative 1/2. Okay, moving on. So evaluate the 6 trigonometric functions of theta. These angle place the terminal side on the x or the y-axis. Your answer can be 1, -1, 0, or undefined. So 0 degrees. So if you think about 0 degrees, so if you're on the coordinate plane right here, you have your initial side, which stays on the x-axis. Then you have your terminal side, but the terminal side rotates 0 degrees. So here is 0 degrees. So the angle, the terminal side, is on the x-axis. It's on the positive x-axis. Positive x-axis. Now, remember that sine is, we relate sine to the opposite side, so the y. And we relate cosine to the x value. And so since we're on the positive x-axis, I know that sine is going to be 0. And because we're on the x-axis, I know that positive x-axis, I know that cosine is going to be 1. And tangent, remember that tangent is opposite, which would be y, over adjacent, which would be x. And since x is 1, in this case, or cosine, because remember that we say cosine is like on the x-axis, because our x-axis is 1 and our y value is 0, tangent is going to be 0. In fact, let me see if I can oh, that was it right there. Interactive trig unit circle. Let me explain it here. So here we have our unit circle. You can see the green, which is the opposite leg, which is also the y-coordinate of the intersection of the terminal side in the circle, and you can see the blue line, which is the x-coordinate. And as the angle is at 0 degrees, so what's happening to the opposite leg, or the y value? The y value is going to be 0 right at the x-axis. And what is the x value going to be? It's going to be 1. If it were 180 degrees, it would be x would be equal to -1 and y would be equal to 0. If I were at 90 degrees, now the y value is 1 and the x value is 0. And if I'm at 270 degrees, then y will be -1 and x will be 0. And you can see at the top right there, again, sine is, we relate sine to the y value. So the y value is 0, so therefore sine is 0. The x value is 1, so cosine is 1. Up here, the y value is 1, so sine is 1. The x value is 0, so cosine is 0. And then for tangent, you can see tangent is in white right there. When you're right here, tangent is 0. That's because you're doing sine over cosine, which is 0 over 1, which will be 0. But up here, tangent is going to be undefined because sine is 1, cosine is 0, so you're doing 1 divided by 0, and you can't divide by 0, so it's undefined. And then over here, x cosine is negative, the x value is -1, so cosine is -1. Sine is 0, so therefore y is 0, so therefore sine is 0. So very cool tool that you can use right there to help you on some of these if you want. Cosecant is going to be the reciprocal to sine. Well, since sine is 0 over 1, that means cosecant will be 1 over 0, so it's going to be undefined. Secant is going to be 1 because cosine is 1 over 1 and the reciprocal of 1 is 1. And then for tangent, same thing as we said for sine, this is going to be undefined. Alright, now for pi halves. Pi halves is the equivalent to 90 degrees. So if you had your coordinate plane right here, the initial side will stay on the x-axis while the terminal side will rotate 90 degrees. So here is our angle of 90 degrees. You can see that we're on the positive y-axis. Positive y-axis. So that means y is going to be equal to 1, x is going to be equal to 0, and the radius or the hypotenuse is always 1. Kind of going back right here, because we're on the positive x-axis, x is equal to 1, y is equal to 0, and the radius will always be equal to 1. And so sine, in this case, sine is going to be 1 because we're on the positive y-axis, and because we're on the positive y-axis, that means x will have to be 0. That means cosine will also have to be 0. Tangent is going to be y over x, opposite over adjacent, so tangent is going to be undefined. Cosecant is going to be 1, since that's the reciprocal to sine. Cosine is going to be undefined. And then cotangent is going to be 0. Because we'll do the reciprocal of 1 over 0, that's how you get undefined, and the reciprocal to 1 over 0 is 0 over 1, which is 0. Alright, now for this next one, we have negative 270. So negative 270, so we have our initial side right here, and then because it's a negative angle, we have to rotate clockwise. So we'll rotate negative 90, negative 180, negative 270. So we have negative 270 degrees. Well, wait a minute. This right here is in the same exact position as pi halves, or 90 degrees. So these angles are coterminal, which means if they're coterminal, they share the same values. The 6 trigonomic values are going to be the exact same because they're in the exact same position. So kind of copying off what I did before, sine is going to be 1, cosine is going to be 0, tangent is going to be undefined, cosecant will be 1, secant will be undefined, cotangent will be 0. So there you go. Just keep that in mind, that coterminal angles, such as these right here, they're going to have the same trigonomic ratios. All 6 ratios will be the same. All right, sketch the angle, find its reference angle. So 100 degrees. So let's think about where 100 degrees would be. So I have my initial side here. The terminal side, because it's positive, is going to rotate counterclockwise. This I know is, oh wait, no, it's negative, so we're going to rotate clockwise. I know that this is negative 90, so an additional 10 degrees over here. And we're going to have our angle right here. This would be negative 100 degrees. The reference angle, this would be the reference angle, and that would have to be equal to 80 degrees. 80 degrees because remember that the reference angle is always measured to the closest x-axis, and the reference angle, the reference angle would have to be 80 degrees because if I'm measuring to the x-axis from here, I know that a complete rotation would be 180 degrees. And so I only went 100, so an additional 80 degrees would get me to the x-axis. So our reference angle is 80 degrees. 320, so we have our initial side right here, and then we're going to draw our terminal side, which is going to rotate, it's going to rotate counterclockwise. A full rotation would be 360 degrees. To draw 320, I would have to be 40 degrees less, and now that's very helpful because now I know what my reference angle is. So here is 320 degrees for theta, and then for my reference angle, that's going to have to be equal to 40 degrees. Again, to get to the closest x-axis, that would have to be 40 degrees to be a complete 360. And so my reference angle is 40 degrees. All right, now we're going to draw angles and get reference angles that are in radians. So the most important part of drawing angles that are in radians and for finding the reference angles, you have to be aware of the denominator. So the denominator pretty much tells me everything that I need to know. The denominator indicates how many halves or how many sections are going to be in the top half and how many sections are going to be in the bottom half. So there's going to be 4 sections and 4 sections here, because pi radians is equivalent to 180 degrees, and I'm splitting that into fourths. So 180 split into 4 parts. 1, 2, 3, and 4. 180, so 1, 2, 3, and 4, also split into 5, 6, 7, and 8. So keep that in mind, that's what we're trying to count up to. We're trying to count up to 23 of those parts right here. So if I rotate a half, like this right here, I'm going to have traveled, I'm going to have rotated 4 pi out of 4 parts. So every part that I have, let me kind of I don't typically like to draw this stuff right here because it kind of just gets in the way and it makes it really messy, but it is also kind of nice for explanation. So this right here is a pi fourths, and this right here is a pi fourths, and this right here is a pi fourths, and this right here is a pi fourths, because I'm splitting up pi, which is 1/2 pi radians, which is again 180 degrees, and I'm splitting it into 4 equal parts. So this would be 1 pi fourths. This would be 2 pi fourths. 2 pi fourths is equivalent to pi halves, which is equivalent to 90 degrees. Oh, that's exactly what we said up here. 90 degrees is exactly perpendicular right there. All right, and so then I have 3 pi fourths, and then I have 4 pi fourths, which is why I kind of like to keep track of each half rotation on the side, or like on the sides right here. It's kind of nice to keep track of that, so that, because remember that I'm trying to count up to 23 right here. So keep that in mind, that's what I'm doing. And then if I rotate another half, that will be another 4 parts, so that'd be 8 out of 4. So I went 4 out of 4, and then I traveled 4 more parts for 8 out of 4. Now 8 out of 4 is just equal to 2 pi. Well, that's equal to 360 degrees. So that's what I'm doing with these right here. Now let me erase this so I don't have to deal with all that mess. So then if I go again, well, that's going to give me 12 pi out of 4. So I'm going to keep track of that right here. 12 pi out of 4. And I'm going to rotate another half. Well, that's going to be 16 pi out of 4. If I go another half, that's going to be 20 pi out of 4. And if I go another 4, that's going to be equal to 24 pi out of 4. So now you can kind of see where I'm at right now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 pi out of 4. But my angle is only supposed to measure 23. So that would put it right here. So that right there is my angle, having measured 1, 2, 3, 4. Wow, I measured a lot right there. Okay, and remember that each section that I go is a fourth. So because I was at 20, so here would be 20 pi out of 4. This would be 21, 22, and 23 right here. And then this right here would be exactly 1 slice of that right there, so pi fourths. So this reference angle is a pi fourths angle, or 45 degrees. Pi over 4 radians right there. So hopefully that's a good enough example. A lot of explanation there, I know. But we'll do something similar here. So we have negative 5 pi over 6. Remember, the denominator kind of tells everything that I need to measure an angle in radians. So that means each half has 6 6 parts, I guess you could say. So that means each quarter has 3 parts. So 1, 2, and 3, 4, 5, and 6, if that makes sense. So, and it's negative, so remember that I'm rotating this way, but I can already see what my angle is going to be measured at. My angle is going to be probably like right here, because if I have each half into 6 parts, and I only want 5 of them, that's going to leave this as 1 out of those 6 parts. So that makes my reference angle right here a pi 6. And my this angle right here is negative 5 pi over 6. So all of these added together would be 6 pi out of 6, which is exactly 180 degrees. All right, and there you go. And oh, I should probably write that down. So pi over 6. You don't have to write the RAD for radians, but you can. Just remember that the reference angles are always measured in positive, even if the angle itself is negative. Okay, evaluate the function without using a calculator. So draw the angle, use the reference angle, and make a special right triangle. And that's what we're going to do for these ones right here. So we're going to draw the angle. So go ahead and draw just a coordinate XY plane, and then we're going to draw 135 degrees. So 135, so this would be 90, this would be 180. I think 135 is exactly in between them. You can confirm, you can use a calculator. So we can do 180 minus 135, and yeah, we get 45 degrees. So this is 135 degrees. The reference angle has to be 45 degrees. So there is our reference angle. And make a right triangle. So use the reference angle and make a special right triangle. Well, if this is 45, that means this is 45. And that would make our side lengths 1, 1, and square root of 2. However, this this leg would have to be negative because we're on the negative x-axis. And we're in the second quadrant. So if we're in the second quadrant, x is negative, y is positive. And the hypotenuse is always positive. And all we want to do is evaluate secant of 135. Well, secant is the reciprocal for cosine. So what would cosine of this angle be? Cosine would be -1 divided by √2. Secant is the reciprocal to that, so secant is going to be √2 over -1, or you can just simply say -√2. All right, let's try sine of -150. So we have -150, so we're going to have to rotate clockwise. So -90, -180, well, that would have to make the reference angle 30 degrees. I'm going to make a special right triangle from this right here. That would be 30 degrees. This would be 60 degrees. So we have a 30, 60, 90 triangle. Opposite to the 30 degrees has to be the smallest side, 1. The hypotenuse of a 30, 60, 90 triangle is always double the shortest side, so 1 to 2. And the adjacent leg, if you can't remember how to find that, you can use the Pythagorean theorem, but it's going to be √3. And because we are in the third quadrant, both x and y are going to be negative. So negative and negative. And we want sine. Sine is going to be opposite over hypotenuse. So it's going to be equal to -1 over 2. All right, 3 pi over 4. So 3 pi fourths, -3 pi fourths. So this is in radians, by the way. So each half is going to have 4 parts. So 1, 2, 3, 4. Well, I only need 3 out of this. Also, it's negative, so we're rotating clockwise. So there's our angle. Our angle here, that's -3 pi over 4, which makes our reference angle pi over 4. And if you guys remember, pi fourths is equivalent to 45 degrees. So we have a 45, 45, 90 triangle. So we have a, So if it's a 45, 45, 90 triangle, we have 1, 1, √2 as our ratios of the side lengths. We're in the third quadrant, so both x and y are negative. Okay, and then, so then we're going to evaluate tangent. Tangent is opposite over adjacent. So this is going to be equal to -1 over -1, or simply just 1. And cotangent. So we have cotangent of -8 pi thirds. So 8 pi thirds. So each half has 3 parts, and we need to go 8. So, and we're negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would be half. So we don't need to go quite. But since we're split into thirds, I think that would put me right about here. It's because I'm thinking about splitting this into 1, 2, and 3 parts. So 1, 2, 3, 4, 5, 6, 7, and 8 right there. That's where it would put me. So my reference angle is going to be 1 pi thirds. So my reference angle is going to be pi thirds, which makes this a 60 degree angle. So this is 60 degrees. That means this is 30 degrees. And we have 90. So if this is 60 degrees and this is 30, this is the small side. So 1, and then to 2 for the hypotenuse, and √3 for the longer side. Both of these sides are negative since we're in the third quadrant. And then we want cotangent. Well, tangent is the reciprocal. Tangent would be opposite -√3 over -1. So we're going to do the reciprocal of that, so negative 1 over negative root 3. So negative 1 over negative root 3, which is 1 over root 3, and then get the radical out of the denominator, so that's going to be root 3 over 3 as our answer. All right, and that finishes 8.3.